We're going to move briefly to chapter 9, and section 9.1 has to do with correlation. But before we get to that, we're going to pull in one of the types of visual displays that I skipped over from chapter 2, which is how to graph paired data sets. When each entry in one data set corresponds to one entry in a second data set, the sets are called paired data sets. One way to graph paired data sets is to use a scatter plot where the paired data is graphed as a point. I've presented you with an example here. I'm sure you've seen these before. This data set represents hours spent babysitting and the money that was earned. Babysitting apparently doesn't pay well. So when you look at the table of values, what we typically do is we assign one of these a variable x, and then the other one we call y, and then we just plot them as points. So 4 and 12 go together in some sense. 4 babysitting hours led to $12 earned. So we plot that as the point for 12 on the graph. And you'll notice too that as usual, we have labels on our axes and a title at the top. I'm not going to have you doing these graphs by hand, but instead I'm going to be showing you how to use Excel to create them. The first major concept though related to these graphs is correlation. When we have paired data, very often we want to know, is there a specific relationship between the two data sets? A correlation is what we call that relationship. Data represented by ordered pairs, just so you know, when we use X and Y, X is the independent, or in statistics, it's often called the explanatory variable, and Y is the dependent or response variable. So what we're typically looking for in our data is to see if we have one of these 4 patterns. We might have a negative linear correlation. So first of all, linear, you can see that this data closely kind of resembles a line. And it's a negative correlation because if you remember some high school math, this is a negatively sloped line. What that tells us about the data is as X increases, Y tends to decrease. So there's an established relationship between those variables. A positive linear correlation, again, you can kind of see a line when you look at this trend through the data points. And this one is sloped upwards, which is a positive slope, positive linear correlation. And what we know when our data looks like this is that as X increases, Y also tends to increase. Now, sometimes when we graph things, we'll find it looks random, like just a bunch of bugs on your windshield. That's no correlation. There does not seem to be any direct relationship that we can observe. It's also possible for data to take on nonlinear shapes, which we'll get to later. But just so you know, that is a possibility that you can see things that don't look like lines. The first example is just a super basic one here. Describe the correlation shown by each scatter plot. So these are cell phone subscribers and cellular service regions, the number of regions we have. And what you can see is the data, again, I can visualize a line running through these points. Because that line is trending upwards, we would say that this is a positive linear correlation in the data. And what that's telling us is that as the number of subscribers increases, the number of cellular service regions increases. So there's a direct connection between the variables. The next one is cell phone subscribers and corded phone sales. I don't know if you're aware, but telephones used to have cords to them. So in this graph, we can see a general downward trend. And so we would refer to this as a negative because it's decreasing, going down, linear correlation. And what that tells us is that as the number of cell phone subscribers increases, the sales of corded phones has decreased. There's one other thing I want to introduce you to before we go to Excel, and that is what a correlation coefficient is. A correlation coefficient is a way to judge how strongly the data is related. So it's denoted by lowercase r. It's always going to be a number from -1 to 1, and it just tells us how well a line would fit that set of data pairs. And as you can see, if R is near 1, the points lie close to a line with a positive slope. That's over here on this end. If R is close to -1, the points lie close to a line with negative slope. And if R is 0, then the points are not close to any line. So this is where we would have no correlation. So when we graph a scatter plot, one thing to do is simply to look at it and kind of judge to see if it looks like the data is linear. But to get more specific, we can judge the strength of that linear relationship using correlation coefficients. In your textbook, it does teach you how to find correlation coefficients by hand. It's a very long and difficult process, and we have the technology. So in this case, I'm just going to defer to that. There's no real reason for you to learn the complicated process of how to do it by hand. But if you're curious, if you look in section 9.1 in your book, you will find an example worked out. One final example here says for each scatter plot below, tell whether the data have a positive correlation, negative, or approximately none, and tell whether the correlation coefficient would be closest to -1, -0.5, 0, 0.5, or 1. So when I look at the first graph here, it kind of seems like the data is sort of heading in this direction, whereas X increases, the Y values are increasing. But notice, they're not hugging the line tightly, they're a little bit more spread out. So in general, first of all, part A, we would call this a positive correlation. And secondly, what would the correlation coefficient R be close to? Well, of our choices back here, 0 doesn't make sense because that's for no correlation. And we also wouldn't choose the negative numbers because we've already established this is a positive correlation. So we're down to two choices. Either our correlation is 0.5 or it's 1. A perfect correlation of 1 would have the dots fall perfectly in a line. Our dots aren't doing that in this graph, so 0.5 would be the more appropriate choice. In graph number 2, you should see the downward trend occurring in this data. And because of that downward trend, this is going to be data that has a negative correlation. In other words, as X increases, Y is decreasing. And if it's a negative correlation, going back to our choices, the positive values don't make sense. 0 doesn't make sense. Now, this data is much closer to being a line than the previous one. So the negative correlation factor here, our correlation coefficient R, would be closest to -1. In reality, it wouldn't be a perfect -1 because to be a perfect -1, your data literally would be a marching line of points. But it's closer to that than it is to -0.5. And the last data set, you've got points, and they're just kind of, it's as if somebody just, dropped a handful of pennies on the floor and they land where they land. There's no direct trend that this data is following. So this would be the time we would say there's no correlation. The closest correlation coefficient of those on the list would be R equals 0. Now we're going to turn to Excel.